Welcome, everybody. Thank you very much for coming over. In this session, we're going to talk about Azure IoT Edge. I'm sure since morning through Satya's demo and keynote, and after that, you've been hearing a lot about Edge. I'm sure you saw the demo where the drone was flying around, and we were using Edge to run AI on it. In this session, we are going to dissect it a little bit more. We're going to go into technical details of how that happens. And also, we're going to tell you how you can actually become part of this whole Edge thing through tooling, through a bunch of marketplace activities, and so on. So we're going to patch it all together and give you more details right now. So I'm Arjuman Samuel. I'm the PM lead for Azure IoT Edge, which is part of the Azure IoT engineering team. And with me are
Emmanuel. Hi, everyone. I'm a program manager in the Arjuman team, so working on Azure IoT Edge.
And hi, everyone. This is Venkat Yala. I'm on the IoT Edge team as well, working with Arjuman.
Thank you. So I'll continue with a little bit of details here, and then Emmanuel and Venkat can come on and show you some demos. OK, so let's dig a little deeper. We know that there is a lot of value, a lot of things that we can do with the cloud. The cloud, with its near infinite resources, storage, compute, a bunch of PaaS services, you can do a lot of this thing. For example, remote monitoring, collecting all of this data out there from IoT devices and bringing it together in the cloud. You can also do monitoring of these devices, which might be at scale, millions of devices deployed out there. You can manage them. You can manage them centrally from the cloud. Then, because of the infinite compute resources you have, you could actually go in and train some AI, which could require a lot of compute, lots of data that needs to run to train those models. Once you do all of that, now you need to think about what do I do with all of that training I've done in the cloud, and how do I make sure that this is also applicable to run closer to your machines? And that is where Azure IoT Edge comes in. If you're running control loops which are very tight, near real-time responses are required from those control loops. Based on intelligence with AI and ML, you cannot depend on a network call and then bring back that AI results. You need to run those models close to your machines. You also might like to pre-process data on-prem. Examples being, typical example being that of video. If you're collecting a bunch of video streams and you're doing some video analytics on top of those video streams, you don't want to send all of those video streams up to the cloud. That would be very expensive. And especially when you're only looking for that one frame with that one anomaly. So might as well do all of that analytics, video analytics on-prem in the edge. Of course, all of that possible only if you have AI and machine learning and so on, where you have trained your models in the cloud and you bring them down to the edge. Offline is another use case here, where what if your edge, your IoT device, is deployed on a ship or on a mining platform, which goes offline. You want that functionality, the same functionality that you would get with connected to the cloud, AI, machine learning, and so on, but you want that available right over there when you're disconnected, when you're offline. Azure IoT allows you to do that. A bunch of things you do with protocols. For example, internally in your machines, in your manufacturing shop floor, in your buildings, you have things like Modbus or BACnet and so on. You need some translation between those. Azure IoT allows you to do that as well. And finally, what if your organization does not want you to stream all that video or face, image, all of that up to the cloud? They want all of that data to remain on-prem because of privacy reasons, regulations, and so on. You can still do all that neat AI and ML on that data, but still maintain privacy and so on. So there's a bunch of use cases that point us to having your processing done as close to your machines as possible. And we do it through what we call Azure IoT Edge. And the way we do that is just creating a consistency between the cloud and your edge. And I'll tell you what that means. The first consistency that we have created here is consistency in the programming model. So you have an application running in the cloud. What if you could take the same application or parts of that application and move them onto the edge? Or if the scenario changes, move it back to the cloud. So if there is consistency between the two, the edge and the cloud, you can actually do that. And we'll demonstrate that today. Now, with that consistency, there is another interesting thing that happens, which is now you really need those cloud development skills, because Edge gives you that infrastructure which is transparent for the cloud and the edge. You really need the cloud development skills. You do not need specific device development skills. You can upskill your developers. You can also have people who specialize in very specific tasks, such as data science. So having cloud skills allows you to also program your devices. I think that is the key here, because of this consistency. So today we are going to demonstrate all of this. We are going to show you how we move models from the cloud down to the edge device, and what is the tooling that we provide, so that it's as simple as clicking, as simple as writing a few lines of code, and then moving your models down there and getting some edge analytics done. Okay, it's important here also to mention that there is a larger context where you have edge close to your machines, but you also have other components on top of it. Now, Edge, of course, gives you a local view. I like to call it the local view of data and alerts and analytics and so on. But then on top of it, all these different sites where you have Edge needs to be connected together. That's where cloud comes back in, where you connect all your Edge deployments together, you get alerts together, you have a single pane of glass which gives you what is happening on each site where Edge is deployed. And then on top of it, you also do not need this operational data in isolation. You need to relate it to other data in your organization. For example, you might have financial data, HR data, supply chain data, which also needs to merge with this. I like to call it the boardroom view. So from the local view to the supervisory view, which is monitoring all the edge deployments, all the way to the boardroom view, which requires this cloud-based analytics and cloud integration as a whole. Okay, so now I'm going to jump a little deeper now that I think we are there, motivated on, okay, how does this whole thing work? Tell us the gory details. Here it is. The first thing, of course, we engineers like to do is come up with some design principles. Here are a few design principles. As you will see here, security is one of the most important ones here. Think about it. If you are moving your workloads from the cloud onto on-prem devices, which might be anything, and I'm going to talk about what those are, but which might be anything, if you're not securing them properly, if you're not putting in the right security frameworks for those devices and monitoring for those devices could be compromised with a lot of bad things happening there. So security has been one of our first top principles that we have invested in. We'll talk a little bit about security here in this session, but we have a whole session, I'll give you a pointer, tomorrow afternoon, where we'll go deeper into security. It's all cloud managed. So when you deploy Edge through our automatic device management capability, you actually get cloud management, cloud control in IoT Hub, which is a service in the cloud, so that you can manage IoT Edge devices at scale. So imagine you deploy millions of these edge devices, and now these millions of edge devices need to be managed in terms of what are the workloads that are going on to these set of devices versus that set of devices. All of that can be done from the cloud. And when you do it from the cloud, it allows you to be consistent, it gives you compliance, and so on. So all of this comes together when you do IoT edge deployments using the automatic device management functionality. Totally cross-platform on the client side. We support Linux, we support Windows, multiple platforms, x64, ARM. And our goal here is that you have a device which is a gateway class device, a smaller device. Wherever your hardware is for your edge device, we should have a way to support that. And the way we do that is through containers. So essentially what we do is we package all these workloads in containers, and then we move those workloads onto those devices, and that gives us the flexibility to go cross-platform. It's portable. You have your modules. I'll introduce those as well. You have your workloads which you are developing in the cloud. You simply move them to the edge. We also have tooling which gives you continuous development, continuous integration. So you have a pipeline where you are developing, testing, staging, and deploying. And deploying may take time, and then you're iterating over it. So we have a continuous integration, continuous development pipeline, and tooling for that. Extensible. I have up till now mentioned that you can take our services in the cloud, machine learning, and so on, and deploy them onto the edge, but that does not stop from your own code to be deployed in the same way. You might have your own code which needs to be deployed onto these edge devices in addition to perhaps AI and ML, but your own code, simply putting it in a container. We provide SDKs in multiple languages for you to do that, putting it in a container, and then hosting it somewhere, and then moving it onto edge devices, again at scale. So this edge gives you an excellent opportunity to manage your own code in a way where you simply use IoT Hub and Edge together to deploy this functionality. So these are some of the very high-level design principles that we have. I'm going to introduce a few concepts here, 4 of those. And with these concepts, I can actually explain how it all comes together. Right? So the first one here is module. Now, modules really are any workload that you want to deploy onto the edge device. Right? They are containerized. You package them in a container, we provide SDKs, and then you simply host them somewhere. So it's a package, the image is hosted somewhere, it could be Docker Hub, it could be wherever, Azure Container Registry, and now you have a container with your workload or with our workload, like AI and ML and so on. Module instance, when this module ends up on an edge device, we call it a module instance, which is running on that edge device, so you could have multiple module instances for that module. Then each module, and this is important again to maintain the security of communication between modules, between the module and the cloud, between devices and the module, you need to have some kind of security. So the first thing for security is each module has an identity. This identity is attestable in the cloud. So it's a unique identity in the cloud for each module instance that is deployed out there, which means you can actually go to each module and you know where it is running and authenticate it and so on. So that, again, is part of the infrastructure that we provide. I'm going to come to twins, but if you're familiar with that, it's really a state management thing for device management, and each module also has a twin, but I'll go into more details there. And finally, we have multiple languages, 5 of those listed here, for putting together a module. So if you have your code, you will simply use one of these modules, these SDKs in whatever language you have. They're on GitHub, and then you'll put together that module and then host it somewhere. The reason why you'll use this SDK is just to make your job easy. For example, for all the authentication that needs to happen for a module, this SDK simply supports it with one API call. With all the encryption of messaging happening, that in any message coming out from that module, going to another module or the cloud, you don't have to think about how that is going to happen. The security, the access control, and so on is all within the SDK. And hence, this SDK is really a tool, open sourced on GitHub, which you use to put together these modules. So module is this unit of compute, your own code, parts of services, which are deployed onto the edge. Second concept is an edge runtime. Edge runtime is really the heart of the system. It is what gets deployed onto your edge device. When you have an edge device on-prem, you deploy an edge runtime. But edge runtime is also containerized, which means you can move edge runtime whenever you want to, update it whenever you want to. So it also is responsible to bring down those modules, now that we have that concept. It brings down any module that needs to be running on that device is all managed by the edge runtime. So think of it as the management plane for all modules coming here. Now in this picture here, we have 3 modules. We have a telemetry module, we have an insight module, and we have an action module. Whatever those are, there's code in there and there's something happening there, and they're talking to each other and to the cloud. But edge runtime brought them down onto that device. And then also is monitoring actively. So it also maintains security standards. So whatever authentication is required for those modules, for messaging and so on, is maintained by the edge runtime. It monitors if an edge module drops off, taking too much CPU, so on, you want to restart it, edge runtime would do it for you. It, of course, uses the underlying container management system, but it would do it for you. It reports health for each module. All communication between the module to module, because you might have an AI module and a telemetry module, they're talking to each other, is going through edge runtime. If it is going from a module to a device, it's also going through edge runtime. If it's going from the module to the cloud or from the edge runtime to the cloud, all of that orchestrated by the edge runtime. So Edge runtime is your core heart of the system, which is sitting on your device, on an edge device, which is deployed out there. It's containerized, and so you can move it up and down. And we'll actually get into more details of how all of this works. OK, so 2 concepts. We have modules. We have the edge runtime. Third, something called routing. I've been referring to this as module 1 talks to module 2. But how? It talks through edge runtime through routing rules. Think of it as a routing table in our network parlance. Right? You put down a routing rule in edge runtime and saying that module 1 should talk to module 2, and edge runtime would simply do that. Right? Now, here is some example. It's actually SQL-like syntax. We have published this language. It's already there in IoT Hub in the cloud. We brought it down to IoT Edge. So from source condition sync. Source could be a module. Module 1 output is a source. Condition could be if the temperature, if the sensor type is temperature, if the alert is true, only then pass on this message. So this gives you a lot of control over what kind of message passing happens between modules, or between module and the cloud, or between device and a module. So this gives you all that control. And then finally, where does this message end up? What's the sync? In this case, it could be module 2. So here is this whole query. Output from module 1, when temperature type is equal, sensor type is equal to temperature, send this message to module 2. And now what you have here is 2 modules, module 1 and module 2, talking to each other only if sensor type is equal to temperature, and you can add more conditions to it. We call these routing rules. These routing rules are set up in Edge runtime because this is the backbone of messaging between modules. You can also write a query which says upstream. Upstream is $upstream is for the cloud. So you can say when it is temperature, or when it is alert, send it to the cloud. So you can also put that down in the routing, and now Edge runtime would simply route traffic up. OK, so 3 concepts: module, Edge runtime, and routing. Last one, device management. If you have gone to Sam's session just before this, you have heard about this, a lot of details there. But essentially what is happening is each device out there and in the cloud, there's a state that we maintain for each device. We call those twins because there are always 2. There is one on the device and one on the cloud. Each of these twins has certain properties. It's really a JSON file with some values in there. And 2 properties which are important to note here are the desired and the reported property. Now, the desired property is owned by the cloud. So the cloud, IoT Hub, will say that this should be the value of whatever, like firmware version should be equal to 1.3. That is your desired property maintained by the cloud, given to the device, ordered that this is your desired property. The device would do something and would report back a reported property, and would report back saying, yep, I'm on 1.3, and then you can actually see the desired and the reported are the same, and now the device has reacted to that. And then, of course, you have other things like tags. You can tag devices based on location, for example, and these are open data. You can put anything there, location or whatever, but you could then query on top of that. And then there is also methods which you can run. If the device is connected, you can actually get a response. Now, what this allows you to do with tags and with desired and reported property, you can actually write queries. You can say, select star from all my devices where location, tag.location is equal to Seattle. I'll get a list of these devices. And then I can act on it. I can say, for these devices, take the desired property to something else. Or give me what is the reported property for this tag. So those are the things that you can do. And then on top of it, you can schedule jobs on top of it. You can say that all devices tag location is equal to Seattle, take them to this firmware version. And this is a job. It just would sit there, look for those devices. Whenever it finds a device which is not in compliance, it would send out a desired property to it. And so all of this is happening in the cloud. Cloud automatic device management services doing this for you. This allows you to scale up. This allows you to deploy millions of devices and not have to think about each one of those, right? Create groups, perhaps, dynamic groups out of it. So you can do a bunch of things with this. So these are the 4 concepts, and we are going to use all of them: modules, edge runtime, routing, and then device management twins. So let's see how it all comes together, right? So I'm going to now see how this, or talk about how we are going to put workloads on a device all from the cloud. The first thing that happens is that rectangle, of course, is your edge device. I'm going to give you examples of those edge devices, hardware-wise. But essentially what it needs is, first of all, we have some security requirements. For example, it should have a security element on it. It should have our security manager on top of it, which is native code, which is used to connect to that security element. And then it should be able to provision itself through our device provisioning service. So with that box, with that physical hardware, you simply deploy it. You do not have to think, OK, do I need to put machine learning on it, on AI? You can do it later on, once the device is deployed. All you need is for the device to provision, zero touch, provision itself to the cloud, and then you can play around with it at scale. OK, so the first thing that happens is after the device provisions, you move a container, which is your edge runtime. Remember, this is the heart of the system. So now you have moved the heart of the system onto the device, and now you have a functional edge device. With the edge runtime in place, what you do is you go to the device twin. Again, it could be done at scale with automatic device management. It could be done for one device. But in the twin, in the desired property, you say what are the different workloads you want to move to this device, right? And then edge runtime would take that in and start moving those workloads down to this device. And all this is happening in containers which are Docker compatible. All this is bringing those containers down and deploying them onto the device. Now, these containers themselves could be AI services, could be functions, could be machine learning, could be your own code, could be anything. As long as they are packaged in the right way, with our SDK, hosted in the right way, wherever, you could be hosting it in any number of ways. As long as you can refer to that as a URI, you can put it in the device twin, and now that will flow down onto this machine. So the first thing you have done is taking a box, which is configured to be an edge device because it has a security manager and so on. But beyond that, it did not have a workload. You deployed it in the field, provisioned it, and now you have your containers, your workloads actually working on it. Second thing you do, you want these containers, these modules, to talk to each other, right? So this is where routing comes in. So those routing rules we talked about, from, to, condition, all of that is set up in the cloud at scale through automatic device management or through a portal that we provide. And you say, module 1 should talk to module 3. Module 3, if sensor type is equal to temperature, send data up to the cloud. And all of that is stitched together. I like to use the word stitched because actually you can stitch these together. It's stitched together in the cloud. You do not have to do anything on the device. In the cloud, you go in on the twins, you say, these are the different routes I need to put on this device. And now they come down, edge runtime picks it up, starts implementing those routes when those messages start flowing in. And remember, as I mentioned previously, each module has an identity. When it was launched, that identity exists in the cloud. Each module, whenever message comes out, we know from where it is coming, so authenticated each message is encrypted and so on. So all that security is already in place for you to do secure processing of data between these modules. Now, the third thing that happens here is each module also has a twin, which actually means each module has a device, a module twin, which can be used to configure that module any way you want. An example would be you have a machine learning model which has been dropped onto this device. It needs some initialization weights, right? And for different scenarios, they could be different. So all you do is you go to the twin of the module in the cloud, and you say, this is the parameter for this variable. Comes down, edge runtime gives it to module, module takes it, implements it, and your code will pick it up and then start running with it. Right? So now what you have done is a box which was empty is now filled up with compute, which you decided where it is going to come. And you can use the same mechanism throughout the life cycle of the device. Right? Tomorrow you want to update this machine learning model, update based on learning and so on, update an AI model. You can do all of that from the cloud without ever touching the device, because through device management in the cloud, you can set up a new route, you can set up a new module to come down, you can remove a module, you can add another module, you can add 5 more modules. Whatever you want to do on this device, you can do sitting in the cloud at scale. So that is really how Azure IoT Edge is deployed. That's how we move workloads to the device, and these workloads could be any of those. Okay. So having said that, oh yeah, finally we also have downstream devices. You could have a temperature sensor, you could have an occupancy sensor. They're connected to that edge device. They're not connected directly to the cloud, and now you are either routing traffic through that route which you define in Edge runtime, or you're doing some processing. You're picking up temperature here, you have a module which looks at the temperature data and only sends out an alert when the temperature is above a certain value. All this is possible because you have different devices connected there. Now, if you see, I have 2 of those. You have devices which are more capable, which can host our SDK, and that means they also have a twin, which means you can state manage this device directly from the cloud, even if it is behind an edge device. Another class of devices could be devices which are like BLE, Bluetooth, Z-Wave, Zigbee, and so on, which do not talk directly to the cloud, cannot, for whatever reason, host our SDK. For those, you would have a module, which would be a proxy for that device. A real example there would be, you have Bluetooth devices over COM port talking to this device, edge device, and in the edge device, you have a module, a Bluetooth module, which is listening in on the COM port, bringing in all the traffic, and then translating it, sending it to the cloud, acting on it, giving it to another module, and doing whatever magic needs to happen with that data. Right? So you have all these options. You could also stitch a hierarchy of edge devices. So you could have an edge device, and then you could have another edge device behind it, and so you could actually manage them all from the cloud. So there is almost infinite possibilities of how you put this architecture together so that it makes sense for whatever you're trying to do. Okay, so that's how it comes together. We'll actually demonstrate this with a real example, which Emmanuel has, but this is how it comes together. Okay, security is an important one. I talked about it as one of our top principles for design. Cross-platform, I already mentioned that. So our security infrastructure, which we provide, would be a very thin security manager, which would sit on 2 devices. We're working with OEMs and ODMs through partnerships to make that happen. I'll talk about it shortly. We're not into designing anything new. We're going to use existing protocols as much as we can, like TLS and so on. We believe we can do it with that. In case not, then we'll go to the community and look for solutions, but right now we can use our existing standards. The third one here is important, especially important to this audience. The way we have structured the security manager, and actually I have a slide which talks about it, we want to abstract the details of implementation of the security infrastructure from the developer. As a developer, you should simply write those modules and the stitching and so on, and leave all the security infrastructure to the edge runtime. Because each device is not the same. Each device may or may not have a security element, or maybe have more. So we want to abstract that out from the developer, and then depending on the capability of the device, you can actually get higher levels of security. And of course, the last one here essentially says that we're working with a bunch of partners. I'll have a few. We've already announced our partnerships with a few silicon vendors, but we are bringing it all together so that right from the ground up, right where silicon is made, to when it is packaged in a box as a gateway or an edge device, we have security thought out there. And this really gives you a little bit more detail. We have our basic premise here is that hardware-based root of trust is the way to build trust in this device with the cloud. The cloud remains your root of trust because that is the most secure place. And then based on hardware-based root of trust, TPM and the like, you actually establish trust between the cloud and this device. And then you go up that stack, you do secure boot, you do attestation of your code which is running there, if the hardware allows you, you could have a secure execution environment, right? Like trusted execution environment or SGX in case of Intel. And then based on that, you go up one more stack, and then you do your protected computing environment where you have your modules running there. And here is a picture of how it all comes together. So the first thing, before I show this animation here, the first thing here is we do appreciate that all devices will not have the same level of security that you're deploying. So you have to do a risk assessment of what is the hardware that you're investing in for Edge, right? And by the way, we have a bunch of programs for that risk assessment and so on. I will not talk about those here. But we provide a range of capabilities for security, starting with enabling our developers to developer Edge applications without having to think about the underlying security layers, which is this. We call it the standard promise. And essentially that means is that there's no hardware-based root of trust. You're a developer. You're developing on a dev box. You don't want to be constrained by a higher level of security for that device. But the HSM PAL, which essentially is an abstraction layer over security, right now simply uses the file system for whatever key storage and so on that is not secure, surely, but it allows you to get started quickly, allows you to build on top of it as you would build on a hardware which has all of that because of this HSM PAL. The next level is based on secure elements, TPM and so on. If you see, the only difference between this and this is you replace the file system with an actual physical hardware-based security device. The HSM could be a TPM. And then your application simply works on top of it, your modules and edge runtime and so on. And then the final one, and this, by the way, I'll talk about timelines and shortly, but this will be available soon. And then finally, we have the secure enclave promise, where it's not only the storage of keys and storage of crypto material in hardware, but it's also execution of sensitive logic, which happens in a protected environment using trusted execution environment or SGX, that we will move some of that as microservices into trusted execution environments. And that gives you a highest level of security. Now, you have to select, obviously, it all depends on the scenario, it all depends on the use case, it all depends how you want to actually, how much risk you are willing to take, and then you might go there or here. Some of the brownfield implementations, devices which have been out there for 10 years, might even go for the first one with a big red, right? Not secure. You have to update to something which is more secure, but still you could use the first model. Okay, so this is about security. By the way, there's a session removing security roadblocks to IoT deployment success. That is day 3, Wednesday at 10:15. So look out for that. Much more details would be coming in this session. Okay, I talked about hardware. I talked about there will be a bunch of different types of devices that you can use for the edge. The way we like to think of IoT devices is over a continuum or a spectrum, where we call them tiers. So sensor tier would be the smallest device, which might be IP, might not be IP enabled. It could be Bluetooth and so on. These are very small temperature sensors and so on. And then you continue going on the right, and you have the gateway tier all the way there. These are ruggedized devices, lots of compute, perhaps even looking like a server, a blade. But these are the industrial strength, high-power devices that you use. Now, interactive tier would be somewhere close to a Raspberry Pi 3, which essentially is what we use for our testing as well. So from the interactive tier all the way to gateway tier, we support all that hardware. Again, Linux, Windows, multiple architectures. You have a device which falls in there. You can actually deploy runtime, edge runtime, and modules onto it. Having said that, it's important to note that your hardware sizing is very much dependent on your workloads. Right? If you are bringing in a small little analytics module, which takes temperature, does average, and so on, you can run it on a very small device. But if you are bringing in a big AI model which does image recognition and video analytics and so on, you might like to go on to the right? So what you select in terms of hardware for that application really depends on your workloads. We support all the way here till interactive tier, Raspberry Pi-like devices, but we're not saying that would work for all scenarios. It depends on what you want to do. Okay, so now how do we ensure, given there is a big spectrum of devices here, right? How do we ensure that you can get your hands on the right device? which is right for your scenario, has the right security if you require that, and so on. So right now we have something called the Azure IoT Device Catalog, which lists like 1,000 or so devices, which is sensors and edge devices and gateway devices and so on. It's a collection of everything. There's a pivot. You can select, I need a device with a GPS on it. It will give you a smaller set of it. You can select, and then you can get those. And these are like 200 plus, I didn't list here, but 200 plus vendors we work with. And you can actually then, right from there, jump off to a vendor website and start buying or talking to those. Now, what we are doing is we are extending this model, this device catalog, to have IoT Edge certified devices, right? So it will still be the same portal that we have with some modifications, but it would be more than based on capabilities of the device. And security is one example. What level of security does this device bring to you? You will be able to select that and know what are the devices I can use here. We will have some leveling, level 1, level 2, level 3. It all depends. So for security, we might have 4 levels. For device management, some additional levels. So we will have a kind of a leveling mechanism where you can actually select the right device for your scenario. So if you are a device manufacturer, I don't know if there are any, we are actually opening this up not just for security, but for device management, for AI. If your device is hardware accelerated in any way, and you want it to be part of this, there's an email over here. Reach out to us. We will let you know how we'll evaluate and certify and so on. And then it will be part of the Azure IoT device catalog for specially devices certified for IoT Edge. Having said that, it's my pleasure to actually announce our first set of partners who have gone through that process, and here they are. There is Advantech, Moxa, and HP Enterprise, as well as Beckhoff, Nexcom, Plathome, Toshiba, and Seed. I'll talk about a few of those shortly, but essentially what they give you is the right platform, the right hardware for Edge. And when you'll find the device catalog updated, you will find that you can select. You can say what level of security you need, what level of device management you need, and then you have the right device here. So these are our initial partners. More would be added soon. Each of those, I think that the ones down there have most of their devices on the expo floor. If you already haven't seen that, please go and see. And there's some interesting, I actually have a video talking about some of the work that they're doing. Which brings us to this announcement. I know you might have seen this already in a couple of keynotes. I just want to reiterate this. This is our partnership with Qualcomm. And what we are doing here is we are enabling Qualcomm, this QC603 is a chip which is AI enabled, which means it's accelerated, and IoT Edge runs on it. And they have a dev kit for this, and it would be available this summer or fall. And if you want to be part of it, you can actually register here. There's a URL here, visionaidevkit.com. And based on that, we will give you early access to this hardware and all the software around it so that you can play around with it. So this URL is important, and we believe that this dev kit, while it's only positioned as dev kit, would lead to many additional scenarios. For example, the same chipset would end up in a robot. The same chipset would end up in a car. And if you're developing for that chipset with those modules which are using the accelerated performance of that chip, you actually get a great performance there. Okay, another thing that we are doing here is, before that, I had to show this. This is that Qualcomm camera. If you want to go to the expo floor, you will see this as well. It has AI on it, Edge on it, and a rich operating system on it. All the processing happens on camera here. For example, you're looking for a face. You don't have to send that picture up to the cloud. Because of Edge, process it here and get an alert. Okay. So this is the camera that I talked about. Now, the other partnership I had shown is with Seed. This is really a dev kit, just to get you all started. Here is the dev kit, part of it, not all of it, just a few components here. Now, the dev kit has these components. Raspberry Pi 3 based. It's the same hardware that we test on. Has a bunch of sensors, including microphones and speakers and other sensors, so you can actually pick whatever you want to connect there. And There will be also a bunch of 3 of those samples that Seed is going to publish out there. These samples are for object recognition, face recognition, environmental monitoring, and speech and language recognition, all based on the cognitive services which Microsoft provides. So they'll be modularized. You'll be able to get those modules in open source. You'll be able to play with them and use this kit to come up with new scenarios. Now, I'm sure you're all around tomorrow. We have 150 of these kits on our booth, so to give free. The kit itself wouldn't be there. We'll give you a voucher, which you can then claim on a website. It will be shipped to you. But these kits are available, and Seed, our partner, is going to actually make it available to all of you, 150 of you. If you visit our booth tomorrow, we will give out those vouchers so that you can get your hands on it. OK, so I'll now invite Emmanuel to take this further. Do you need this?
Thanks, Ashman. So this kit is very convenient because it comes packed with sensors. But what I really love about it are the samples that comes with it, as Ashman mentioned. And it shows you pre-built modules that are pretty complex, like how to build a voice bot or an object identification. But wouldn't it be even better if you had one library to find all those sample modules? If you had a one-stop shop to discover pre-built modules that you could just reuse. Wouldn't it be even better if you had a certified library of those modules? Well, today, I'm glad to announce that an Azure IoT module marketplace that will be coming very soon. And so what it means is that it will enable all developers to save some time. So for instance, if you want to integrate your code with a Modbus machine, Modbus is a common industrial protocol. Like in most of smart meters in smart buildings, for instance, use Modbus. Then you probably don't want to write this protocol translator yourself. And so now that it's part of a marketplace, you can find it there, and you've got the guarantee that it runs well with Azure IoT Edge. The other good news is that for module developers who have put a lot of effort into building their own modules, well, you can share this module. And the first stage, it will be free, but we'll add some monetization tools and capabilities to the Azure Marketplace so that you can make some money out of it. OK, do you want to have a sneak peek at how it looks like? Yeah, OK. So here I'm on the test Azure portal. And sorry, I'll walk you through all the way. I'm on the test Azure portal, and I'm clicking onto the marketplace section, going through the Internet of Things. And here you go. You've got an Azure IoT Edge category right here. 3 modules are listed here. One that helps you with your development to simulate a temperature sensor, a Modbus that we just discussed, SQL Server as an Edge module. And there are a couple more. So really, you've got this browse experience, but you also have a search experience that is provided with this Azure Marketplace. So if you, instead of building a solution for a Modbus machine, if you're more interested by interfacing your solution with an OPC machine, which is another very common industrial protocol, you could start typing for OPC, get all the OPC Edge module, select this one, read the description. It's useful to connect to an OPC US server. That looks promising. And then from there on, you'll be able to see the terms of use of the partner and acquire it and use it and integrate it in your solution. All right. So now I would like to talk about another pre-built module that will also be in the marketplace. But this is an AI module. And so I would like to walk through a couple of AI patterns that we're seeing when deploying AI at the edge. And also showing you the developer experience on how to build an AI solution at the edge. Okay. So I'm choosing custom vision because it's a really easy way to build an image classifier. So you don't need to know anything about AI. So the way it works is it's a cloud service where you can just upload pictures, label them, and then you click on a train button, and you just have to evaluate how good are your results, and you can iterate from there. So really no AI knowledge. So we'll use this as an example. And so what can you use an image classifier for in the real life? Well, here are just a couple of ideas, but there are many, many more. So especially in the IoT world, you could use this in the case of a smart city, which has like, let's say, surveillance cameras a bit everywhere. It could detect like road traffic condition, or in a smart building or a smart airport, you could estimate wait lines, or still in a smart building, help people find a parking spot. Those kind of applications that you can all build with an image classifier. But there are like really many more. Okay, so before deep diving into the demo, really would like to make sure that everyone understands the key concepts to understand what's going on behind the scene. So it starts by, so we'll build an image classifier on an edge device. And it starts with first reading the frames of the camera, right? So we'll build a custom module to get those frames that will send them to an AI service. We'll use the custom vision service in this case. And then we'll write another custom code module that will blink an LED because it's an IoT demo, right? So then we'll package all those custom codes into Docker containers and move all those containers to an Azure Container Registry in the cloud. And then we'll write a deployment manifest that will push to the Azure IoT Hub service. That is the cloud service to manage all your edge devices. And then the IoT Hub will push this deployment manifest to the edge devices. And so once the edge device receives deployment manifest, it will know that it should start downloading all those containers, install them on the device, and start monitoring them on the device. Right. Zooming in one level deeper, so now zooming in on an edge device. So we still have our three modules here, camera reader module, custom vision module, the display module. And so I'd like to talk a little bit about communication patterns between modules. So the first one, inputs and outputs, well, there's no magic here. You need to get the frames from the physical device, right, from the camera. So our camera reader is doing that. But then to share images between the camera and the AI service, because images are typically pretty large, so whenever you have to deal with large media files, the best pattern is to share them through either HTTP or through WebSockets by using the network bridge that the Azure IoT Edge has built in. So all modules are connected to the same network bridge through the Azure IoT Edge runtime. And so that's how you can transfer large files. But it gives you a tight coupling between your two modules. So if one goes down, the other goes down as well. And you can't do broadcasting with this kind of pattern. So as soon as you only need to transfer small blobs of data, small JSON files, like an object has been detected, for instance, then a better pattern is to use messages, the messages that Archmont introduced. So in our case, the camera module is sending messages to both our display module and also to the cloud. It's a publisher-subscriber pattern, one-to-many, and you can define filters for those messages. Okay. So I've got a Raspberry Pi here. now onto the demo. I've got a small Raspberry Pi here. And I will deploy an image classifier on it. So just to show you the image classification I've prepared. So I went to Custom Vision website first, signed in, and then uploaded pictures of apples and bananas. So here, pictures of bananas and pictures of apples. So as you can guess, we'll try to classify fruits. So I've trained my model already. All the training happens in the cloud. And then when you're ready to go and you're happy with your inference, you can export this model. And as of today, there's a new option in this Custom Vision website that enables you to really, just in one click, export and build Azure IoT Edge module. So you can use this Docker file for Azure IoT Edge option, choose an operating system, download it, and that's how you get your module. So I've already downloaded it, unzipped it, and now I'll talk a little bit about the developer experience and through the demo. So I'm in VS Code. I've got the Azure IoT Edge extension installed. So it's this extension here on the bottom left corner. And so you can already see that it has a list of all my devices that are connected to my IoT hub. This extension also gives me a couple of templates. So I've built my solution based on this new IoT Edge solution template. This is the one that you can see here. And in here, I've copy-pasted the image classifier service that the Custom Vision website has given me. So I can also zoom in on a device, and here it gives me all the list of modules that have been already pushed down to the device. It also gives me the state of those modules. Now I can also start monitoring for all the messages that are being sent from the device, my Raspberry Pi here, to the cloud. So let me do that. OK. So it starts monitoring, and some messaging are already flowing. So now let's see if our model works. So I've got an apple here, and I'm putting it here. And I've got a 99 probability that it's an apple. It's blinking. Yes, perfect. Thanks. So now we'll try to go even a bit further to show you how a deployment works all within VS Code. You can do everything in VS Code thanks to this extension. So what we'll do is we'll try to have it detect an orange. So if I put an orange right here, it hasn't been trained to detect an orange. It actually, the algorithm is tricked, and it believes that it's an apple. So I will update the model. And I've already prepared another model with pictures of oranges. OK, so I've just changed the model TensorFlow file that has been given me by the Custom Vision website. And now I've got this module manifest, and I'll update the version of it. And this is where the module manifest is convenient to whenever you need to target several platforms like AMD or ARM or having some test files. So I'll update the version here. And now what I can do in just one click, I can build my full IoT Edge solution. And what this does is that it compiles my 3 modules that are part of my solution And as soon as those modules are built, it will push them automatically to my Azure Container Registry. So we can look, in the meanwhile, we can look at what a deployment template looks like. OK, so the building is done, and that's pushed everything to my registry. And here I've got my deployment manifest. So it tells the Edge device that it should install first the Edge runtime, the Edge agent, and the Edge hub. And then my module that makes up my solution, the camera capture module, the display module, and the image classifier module. It also has the routes that sends message from my camera module to the cloud, or from the camera module to the display. OK, so now I will push this deployment file to my Raspberry Pi. And so this tells the Raspberry Pi that now it should download the new version of the image classifier. And so we can look at the state of the modules through the Azure IoT Edge extension here. So this module is being down. It's pending an update from the image classification algorithm. Now it's back up. And there's an orange tag, and the LED is now orange. So we've successfully updated our model. All right, so that's really powerful tool when you're a single developer. But what about when you're in a teams of developers? Or what about when you're an operator and need to manage a large fleet of devices? So the basics first. So we define the developer persona as someone who does all the development work, who is familiar with VS Code, who does some testing of the solution, who wants to continuously iterate to automatically add its changes to the solution. And the operator persona to manage large fleets of devices, to prepare deployment, to stage deployment and test those deployments, and make sure that all the devices are running properly as they should. And for both of them, so especially for DevOps, so the in-between category, we've got a great tool called Azure IoT Edge for VSTS. And so what this does is that it enables you to automate your pipeline end-to-end. So as a team of developers, you can use VSTS with this extension to do continuous integration. So you're working on your branch, you add your changes, and the VSTS build can be defined to run some tests automatically. And as soon as you want to do a pull request to push those changes to your branch, you can define VSTS to automatically deploy this build to a test device, let's say. And then once you're happy with your developer branch and want to push this to the main product branch, then you can define other triggers to deploy maybe to 10 different devices or to larger rings. And then the operator can take it even further and maybe even all the way up to automatically deploy to all devices if all tests are successful. So really, between the VS Code developer extension and this Azure IoT Edge VSTS extension, you can build an automated pipeline and have do all your development work in VS Code. All right, there's one last thing I would like to touch base on around the developer experience, and it's about event-based programming. So that's really a vision and something that we're pushing forward in the Azure IoT Edge team is to go towards this an event-based programming model. And the reason is because events are easy to understand. and easy to program with. And so it's about going one step further than what we have with messages, because so events gives you this loose coupling between modules, and allow this publisher-subscriber pattern, so this one-to-many relationship. But so we will even go further by adding integration with Azure Event Grid, so that you can not only have communication of events between modules and between module and the cloud, but extend that to even more devices. Like HTTP delivery is even more cross-platform. And the other main advantage of Azure Event Grid is that it will give you consistency and symmetry with the cloud. So you will have the same APIs, the same semantics, the same filters, whether your events are being triggered by an edge device or by the cloud, right? So that's really where we want to go. So if I take back my example of an AI application here, kind of the same thing. The camera can trigger event. I've got a new frame. The AI can trigger an event. I've detected an orange or an apple. And then the display module can catch those events. So the Azure IoT Edge runtime, the cloud can as well. But now with Event Grid, other devices can even get them. And so if I take the example of a parking lot, which has a surveillance camera in front of it and which detects car plates. And then as soon as a car entering the parking lot is detected, it can send a message to an event to the gate to say like open the gate. Can also the monitor can also receive this event and display all the plates being let into this parking lot. And of course, with this consistency with the cloud, you can use all the integrations that Event Grid already has. So you can push those events to Logic Apps, to Azure Functions, and to any of the services that has webhooks, so a lot of them. Let's have a quick look at a code snippet. Because one more thing that Event Grid gives you is that it makes your code even easier than when using messages. So just quickly, we'll go through how the code would look like with Event Grid. We did a proof of concept to run Azure Event Grid in the runtime. And so this is what the code looks like. So you initialize your Event Grid client. And then it's as simple as soon as your AI algorithm detects that there's a new car coming in, you fire an event and you publish this event. And then my other module, parking module, can use a webhook to register to this event and do something as soon as an event is detected. So really simple, and that's really the direction where we want to go. All right, that wraps it up for the developer experience. And now I would like to invite Venkat on stage to discuss about Kubernetes.
Thank you, Emmanuel. From the beginning, one of the core principles of Azure IoT Edge was to be built on open standards. The advantage of this for you as a customer is first-class support for best-in-class technologies in the container ecosystem. For instance, Kubernetes. So today, I would like to show you how you can use Kubernetes concepts and primitives to do Azure IoT Edge deployments. To be clear, we're not talking about high availability or disaster recovery today. HA and DR are on our roadmap But what we're really talking about is how you can use the power of Kubernetes to actually deploy software on your edge devices. So how does this look like? So I have the architecture diagram on the right here. We leverage the virtual kubelet project, which lets you create a virtual node in your Kubernetes cluster. A virtual node is not a VM like most other nodes in the Kubernetes cluster. Instead, it is an abstraction of a Kubernetes node that is provided by the virtual kubelet. And backing it is actually an IoT hub. But to the Kubernetes scheduler, it doesn't look any different than any other node. It can schedule workloads to it and just treat it like any other Kubernetes node. So what happens when workloads are scheduled to this virtual node? That is where our edge provider comes in. And that's depicted in the architecture diagram in the blue boxes there. So what the edge connector or the edge provider does, working in tandem with the virtual kubelet, it takes the workload specification that comes in from Kubernetes, converts it into an IoT edge deployment. And then the IoT edge deployment is then shipped back to the backing IoT hub for this virtual node. The IoT hub, in turn, pushes this deployment down to all the targeted devices. So that's how the whole flow works from the cloud, through the virtual kubelet, through the edge provider, down to all of your edge devices. So that's the architecture. I think it's quite nifty. Even better, I'm happy to announce that the edge provider itself is open source. And you can check out this blog post at the link below to get more details on that. So why is this useful? Why should you guys care? We think this enables some really powerful use cases for various scenarios. If you attended Sam's talk, Sam talked about how you can manage as one single unit a software deployment that has both edge components and the cloud components. Now, that is a very powerful idea. Another super interesting use case is using this technology to manage devices at scale across multiple IoT hubs and using the power of Kubernetes to make this happen. How would you do that? What better way to find out than a demo? So let me just get quickly set up here. Okay. And we'll switch to one. So of course, we are talking about Kubernetes, so everything's in the command line. So this is our setup right here. Let me explain what's going on here. So on the left, we have a Kubernetes kubectl command that is used to control the Kubernetes cluster. And this is connected to the Azure Container Service or the AKS cluster in the cloud. So if we get the nodes from this cluster, you will see that it has only one node. And let me start up the thing right here. OK, cool. So as you see, you have one cluster, one node that is there in your cluster, right? So that is a physical node that is backed by a VM. On the right, we have two edge devices. These devices are actually VMs on my laptop here. As Arjmand and Emmanuel talked about, they are currently running the Azure IoT Edge runtime. So they are provisioned with the IoT Edge runtime. But the configuration for these devices is completely empty. So as you see, the containers that are running on these devices is just the agent. And just to explain what you're seeing here, this is just a listing of the containers on the system that is being refreshed every 2 seconds. So when you have an empty configuration, you will see no other container running except the runtime, right? And now on the left, we have the Kubernetes node. What we want to do is use Kubernetes to deploy software on these edge devices. Now, there are no smoke and mirrors here. These are actually live VMs that are connected to a live IoT hub and to a live Kubernetes cluster. So how do we go about doing that? So our first step is to create this virtual node that I talked about. And to do that, we can use something called Helm, which is a package manager for Kubernetes that lets you create a cluster. So go right here. There you go. So what this is doing is this is creating a cluster. This is creating the virtual node in your cluster. And we are passing it, so this is all the open source project. So we are passing it a Helm chart, which is like an application. And to that, we're passing it some values. So quickly looking at the values for this, like I talked about, you have the virtual kubelet image and the virtual provider image. Also, you have the secrets key. That is your IoT hub connection string. Remember, this virtual node is actually backed by an IoT hub. So you need to give it a connection string. And we're using Kubernetes secrets to manage that so that your secrets are well protected. And the node name for this particular virtual node is going to be called IoT Edge Connector Hub 0, right? So now we exit right here. Now if I do kubectl, K is just an alias for that, get node again. You see right here, the virtual node has shown up. Now you want to deploy software to this node, right? You want to deploy a software specification that gets changed into a Kubernetes manifest that gets changed into an IoT Edge deployment. So for that, let me quickly do that. So I do K, apply, minus F, and then give it a sample deployment. So while the sample deployment is going on, let me open the sample deployment so that you can see what's going on. So here, this is a traditional Kubernetes deployment. The key things to look at here are the name of the deployment itself. It's the temp sensor. We are requesting one replica. That means one copy of this application. And the other annotations that we use here are saying that this is an edge deployment, and these are the tags or the device selector query that needs to go in for this particular deployment. And then these are all Kubernetes concepts. But finally, if you look at the containers, this is finally the containers that you actually want to run on this device. So here, we talked about the simulated temperature sensor. This is how it looks like. So this Microsoft/IoT Edge simulated temperature sensor is a container image. We say this is what we want to run on the edge. And we map the desired properties, again, that Ajman talked about, into the config map. And if you see on the right here, the temp sensor module has immediately shown up on the edge device, right? And now you must be wondering what's happening on the device at the bottom, right? Why is it not connecting anything? Turns out that that device is not actually connected to hub 1, right? It is connected to a different hub. The device on top is connected to a US hub, and the device at the bottom is connected to a Europe hub. And also turns out that IoT Edge deployments are scoped per hub, under a particular hub. So if you have a deployment in your US hub, you would have to copy it and replicate that exact deployment into your Europe hub. And that is how you have to manage. Let's say you have an Asia hub. You have to copy it again. Let's say you make one change. You got to change it in your US hub, in your Europe hub, and in your Asia hub now. This gets pretty tedious very quickly. Can we do anything better with that, with what we built? So let's see. I think we can. Extending the concept of the virtual kubelet. I said there is one virtual node for the US hub. Can't I have another virtual node for my Europe hub? Yeah, let's give it a try. So I use Helm again to install the same one, and I give it hub 1. So the options that I gave it is hub 1. Hub 1 looks exactly like the other hub, except the connection string that is using is a different connection string that is backed to another IoT hub, to our Europe hub. So as you see, 2 instances of this program are being started up. The first hub 0 IoT Edge connector is already running. The second one is being created, right? So if I go back to this screen here and do kubectl get node, you see our hub 1 has shown up. Hub 0 US, hub 1 Europe. So how are we going to actually get this hub? How are we going to get deployments to this hub? Are we going to create a new config file and then paste it to another hub? You can certainly do that. But because of this cool integration with Kubernetes, you can do something like Kubernetes scale deployment, and this is the temp sensor deployment. And then you say, remember I told you about you had replicas 1? You can say I want 2 replicas of this. So immediately, a new specification from Kubernetes is going to be sent to the scheduler. The scheduler will try to figure out, OK, which node can I send this to? It is going to send this to hub 1, which is our Europe hub. And very soon, you should see that coming along. And if you look at Kubernetes, kubectl describe deployment temp sensor, you can see that this particular thing has scaled up to 2. And right away, you see the second hub, with 1 line of code, without changing anything in your configuration, has come up here. You can take this a little further. Let's say you want to update this deployment and get a Modbus module running over here, right? So what we can do is we can then just do Kubernetes apply -f, and then give it an updated deployment. So again, this is a new module that you sent up. So if you look at the deployment manifest again that we have, like describe the deployment, you will see that we want a new deployment. It has automatically scaled down your old deployment to requiring 2 replicas, and it has scaled up a pod specification that is giving you the Modbus module. So as you see, our hub in the Modbus module has immediately started showing up here, right? And then Modbus is shown up here, and Modbus is going to show up here as well. So you just have to update a requirement. You just update the deployment, and you do it right there. And let's say you made a mistake, and you want to roll stuff back. Do you have to find the old module? No. Again, because of the Kubernetes deployment that we have here, we can do something like Kubernetes rollout undo deployment temp sensor. So as you see over here, your Modbus module showed up in both these things. Now the Modbus module will now roll back to the previous version. So do you have to keep track of all the configurations that you have? No, it actually gets even better. So if you do Kubernetes rollout, kubectl rollout history deployment temp sensor, you can actually see all the revisions that your deployment has gone through. Now think about this for a minute. This is like system restore points, right? Like on your laptop, you can go from one configuration to the other, except this is going to change the configuration for your edge, hundreds or probably thousands of edge devices all over the world, just with one command and without having to write a single line of code. Now that's amazing, I think. Thank you. That's my demo.
Thank you very much, Venkat. As all of us who have done demos would realize, I was on the edge of my chair here. With all these live demos happening, it all worked. Thank you for that. A few more minutes, and then we are done here. Next slide. Yeah, the next slide. OK, so the question really is, when do we get our hands on this? So most of it, all of this is out there. We are in public preview. You can get the bits today and start playing with it. New things are coming in the next couple of months, which is when we are going to GA this, Azure IoT Edge, including support for security, HSM-based support, zero-touch provisioning of devices. We are going to get language support across all the SDKs we support. We are going to open source. So Edge Runtime is going to be open sourced with an MIT license, which means you can take Edge Runtime and change it, do whatever you want to do it, any innovation that you want to do with it. And also certification program for IoT devices, which is coming soon. I explained that, but it will be coming in the next couple of months. So those are some of the things that are there. Next slide. Just to wrap up, Azure IoT Edge allows you to bring edge services from the cloud to edge devices, also your own code, whatever language you want to do that in. You can manage these devices at scale and securely from the cloud. Just to close the session, I think we have we have a bunch of additional sessions. You can look those up. And then we have a customer who's
Through Microsoft's partnership with
I'll let Rashmi
Hitachi,
talk.
Renesas Eastern, and Platzome, we've been building a solution for predictive analysis, processing large amounts of time series data acquired through Hitachi's new generation of award-winning sensors. Applying these sensors to precision engineering tasks such as metal grinding and metal cutting allows Platzhome to obtain critical data that reduces training time for their new engineers.
歪みセンサーからの高精度データを数値化して可視化するためにはクラウドが最適だというふうに考えました。クラウドにデータを全部上げてしまうとどうしても遅延が生じてしまいます。その時に思いついたのが Azure IoT Edge でした。
Hitachi was working with the University of Shizuoka as part of a research project, and now they're looking at how they can leverage this technology for their customers' use, whilst applying broader contextual analytics to the data in the cloud. There, data from multiple gateways can be combined to perform advanced analytics for multiple sources.
我々の研究室では切削加工における工具刃先で起こっている物理的な状況について解析をするという研究を行っています。熟練技能の方が非常に難しい加工をされている現場というのはあるわけですけれども、若い方に伝承するのが難しいです。誰でも使える数値データとして捉えることができる、ここは非常に面白い点じゃないかなというふうに考えています。非常に高価なセンサー、あるいは大型のセンサーを使って力を計測すると、そういったセンサーはそのまま生産現場に導入するということが非常に難しいです。今回新たに開発された半導体センサーというのは従来型の歪みゲージに比べて1万倍以上と非常に感度が高い、そういう素晴らしい性質があります。
Microsoft was able to help by providing Azure cloud services. Collecting this data and processing it close to where it was collected ensures that it can leverage the insights and take action immediately. The combination of Azure IoT Stream Analytics on the edge and cloud analytics allow them to digitize and visualize data from their strain sensor in real time without latency.
That brings us to the end of this session. Thank you very much for that. I believe we have, if we have questions, we are here. If you want to ask any question right now. How are we doing on time? I think we're anyway over, right? We are over, so we are here, by the way, all of us. Thank you.